So we have a non-right angle triangle, meaning none of the angles in the triangle is a right angle. Now we're given two sides. We're also given two angles, one known and one unknown. So here we have the unknown, which is theta, and the known being 71 degrees. Now, which formula can we use to find the value of the unknown angle? That is the big question. So let's think about this. We have the angle here, which is 71 degrees. We have the side here, which is 22 millimeters. Notice that the angle of 71 degrees faced the side of 22 millimeters. So right away we can see with the line we have a known and a known side angle and a known side. We can create another line which will make an X with the other line. Let's look at it. On one end we have a known, and on the other end we have an unknown. As long as you have this situation, we have three knowns and one unknown in an X, then you use the sine rule. Now what are we trying to find? We're trying to find an angle, right? So we're going to have sine of the angle we're trying to find over the side that it faces. In this case, theta is over 22 millimeters. So we're going to put 20 millimeters here. Is equal to the next angle that we have here is 71 degrees. So it's going to be sine. Now please note that we have angle above the division line. In other words, angle in the numerator for this fraction. So for this fraction, we should also have angle in the numerator. And remember, once you have an angle, you should have sine next to that angle. Known or unknown. So opposite the 71 degrees, we have 22 millimeters. So now once we have this situation, we can now proceed to find angle theta. To find theta, we're going to remove the 20 first. So the 20 is in the denominator. In other words, it's dividing sine theta. So once transposed, it will move from division to multiplication. And once it multiplies, therefore, it moves from the denominator to the numerator. So we'll have sine theta equals, and as I said, 20 move from the denominator in this side of the equation to the numerator in the other side of the equation. So we have 20 sine 71 degrees. It's 20 here is 20 millimeters multiplied by sine 71 degrees. But I'm going to leave off the units for now. Now I'm going to put back the 22 millimeters, 22. Then I want to find theta. Remember, that's the goal. So when I transpose sine by itself, notice I'm moving sine by itself, not with theta, but just by itself. Once that's the case, we're going to use sine inverse. So sine inverse of 20 sine 71 over 22. So you put that in your calculator, all right? Don't put the degree symbol in your calculator, of course not. Just put this that you're seeing here in your calculator. You may have to put the 71 in brackets. So open bracket, then you can click on the ABC button, or if you have a button like this, a fraction button. Once you insert that, then in the numerator, you'll put the 20 sine 71, and in the denominator here, you'll put the 22. Close bracket. All right, now to get sine inverse, of course, this part is very essential. To get sine inverse, you'll need what? To press the shift key. You may not have a shift key on your calculator. It could be this key that says second function. So either one of these, and then you press sine. Your calculator will display what? Your calculator will display sine inverse as a result. Open bracket. And so here, you will enter the information. 20 sine 71 divided by, so careful when you're entering this. So you say 20 sine, open bracket, 71, close bracket, then put division, and then press 22. Then, of course, you close bracket. Remember, you want to close this bracket when you're done. And you should get what value? 0.26747,808. All right, that's what's displaying on the calculator. I'm sure they have more digits, but this is what my calculator can hold. So theta, the unknown angle here that I'm trying to find, let's say to three significant figures. The first non-zero digit is my first significant, so that's 5. my second significant figure. And the third one, which is the last of the significant figures I want, I would have to check the next digit. This next digit is 6, falls in the category of 5 or more, so I'll add a 1 to this 2, that would be 3. So it's 59.3 degrees. Remember, my angle should be in degrees. And that's that. Okay, so hopefully that was helpful. Now let us move into another question. Let's look at this one. So we have this triangle, PQR. Now, once we have angle P here, I will label this side as common letter P. And once I have angle Q here, the side that faces it, I'll label it as common letter Q. And once we have angle R, the side that faces it, a small common letter R. Okay, so now I need to decide, am I going to use the sine rule still? Can I get an X out of it? Well, let's check. Do we have, now if you go back to the first question, did you notice that we have, for this line here, we have an angle at one end and the side, the measure of the side on the other end. The known angle on one end, the known side at the other. So known, so that's a full pair. For the other line, we have a half pair. In other words, the side is known, as in this, but the angle is unknown. So we use sine rule in this case. Now let's go to this one. Do we have the same scenario here? Well, if you look at this, we have a known side, but an unknown angle. If you look at here, we have a known angle, but an unknown side. So we can't use the sine rule. For sine rule, we need to have a full pair. We have a half pair here, in other words, we have an unknown. We have a half pair here, in other words, we have an unknown. So we cannot use the sine rule. But we have another rule that we may want to consider, and that rule is the cosine rule. Now for the cosine rule, we have this formula. A squared is equal to B squared plus C squared minus 2 times the product of B and C times cosine of the angle A. Notice that we have common letter A here and capital letter here. Well, this is the situation. So let's say we have the triangle A, B, C. All right, so triangle ABC. Now this is angle A and it faces what? Side little a. We have angle C and it faces what? Side little c. We have angle B and it faces what? Side little b. So when I talk about side AC, I can say side B. Notice when I say side AC, I did not mention B, so that's letter B. So we can use B to represent AC. When I say side AB, I didn't mention C, so we can use common letter C. As we can see here, common letter C represents AB. And when I say BC, notice I didn't mention A. So this side, BC, I can actually use A to reference that side. But again, you can actually see that opposite side A is angle A. So we can see side faces the angle with the same letter. Just one is common, one is capital. Okay, so if you notice in this cosine rule formula, what do we have? We have a case where we have side A facing what? Angle A. And that's how it always is. Whatever letter you have here, you would have the same letter for the angle. Now these are the sides. A, B, and C are the sides. B is the side of the triangle, C is the side of the triangle. They are common letters, right? Common letters are used for the sides of the triangle. We have B and C here again. Now this B is the same as this B, same measure. This C is the same as this C, same measure, right? Referring to the same side. Okay, so now you get that. Now I also want to mention this, right? I want to mention that, see these two sides, B and C, again repeated here. Those two sides are the sides that form the angle that comes right after cosine here. So B and C form angle A. Let's look at this triangle here. Do you notice that we have sides what? Let's use a different color. Let's look at this. We have side what? B and side C. Let's look at it. This is side B. This is side C. And do you notice that side B, which is this side here, and side C, which is this side here, they actually do what? They actually form the angle here, which is actually angle A. So sides B and C are the two sides that form the included angle. Okay, so we have B and C forming angle A, which is this angle right there. So that we want to keep that in mind. And what about A here? We didn't mention A. Well, A is the side that is what? Opposite. A is the side that is opposite the angle A. So if you look at this, opposite this angle A here is what? The side A. All right, so let me just clear this. Well, we said that this is the angle that faces a particular side. Angle A facing what? Side A. And angle A is formed by the two sides B and C. Got it? So these two sides B and C form angle A. B and C form angle A. And opposite angle A is side A that we have here. Now when you look at this triangle here, what are you seeing? You're seeing these two sides that form this angle. So these two sides will be our B and our C, the two sides that form the included angle. And opposite the included angle is this side. So in relation to this formula, we may not be given the same letters, but we should understand what these letters are representing. So again, B and C represent the two sides that form angle A. What two sides form the 81 degrees? The 9 centimeters, in this case Q, and R, the 7 centimeters. These two sides, R and Q, form angle P that we have here. So the side that faces this angle is little p. So that's what we'll put here, little p that faces the angle. So we square it. And at the end we have cosine of the angle that faces P. Just like we have here, the angle that the side that faces angle A is side A. The side that faces angle P, side P. So what we'll have here is capital P for the angle that faces side P. And B and C being the side that form angle A. So the side that form angle P is side R and Q. So we'll have R squared plus Q squared minus 2 times, again, BR and Q times cosine P. So put that into perspective, we have P squared equals R being 7 squared, Q being what? Q being 9, so we put the 9 squared minus 2 times the product of R and Q, so R being 7. So whatever number we have here, put it here. Whatever number we have here being 9, put it here. Cosine of angle P being 81 degrees. Okay, now let's just take this out just so it doesn't confuse us. All right, so this could be cosine of the angle, which is 81 degrees. So we have P squared is equal to, now what you can do here, you can just plug this entire expression in your calculator. If you have a double display calculator, you can put it in. If not, then you can just break it down. 7 squared is 49. 8 squared is 81. And then we can say 2 times 7 times 9. You can put that in your calculator. We get 126 multiplied by the cosine of 81. So cosine 81, no inverse here because just straight cosine, and we end up with 0.15643, etc. Right? Now again, you want to ensure that you multiply these guys, and so you're working out these two parts separately, right? So P squared is equal to what? 49 plus 81. That's give us 130. Always do multiplication together before you add or subtract. So that's 126 times cosine 81, or you can just say 0 point whatever. But I can just multiply this part in my calculator. 2 times 7 times 9 times cosine 81. I think that will give us a little bit more accuracy than writing down everything. So 126 times cosine 81, that gives me 19.710744 4, 2, 6, etc. But if I want to write up to 3 decimal places, I always get to use up to 3 decimal places before the final answer. So that's 19 point, and I'm going to write the 7, that's first, second, and third decimal place. So I'm going to chop everything off. Then I've checked the next digit. This 7 falls in category of 5 or more, so I'll add 1 here. And so my answer is just going to be, taking all this off, a 1, replacing that 0. Alright, so now I'm going to have P equals the square root of, now I need to work out this portion here. What is 130 minus 19.711? That's 110.289. Now you might be wondering, okay, how did I get the square root there? So let's go back to this. Let's go back a little bit. So I put back this p squared and I work out this portion, which gives me this, up to 3 decimal places. To find p, I need to remove the square. To move the square, once it transposes to the other side, becomes the square root. If not, if you don't understand that, then I can say I square root the square, take it off, so I square root the side as well. So technically, it's like you transfer the square over as square root. And the square root of that, 110.289 will give us what? So I press square root and I press answer that I have originally, which is the 110.289. And I get 10.5. Let's up to 3 significant figure. Let's be 10.5. Okay, I have 0.18, blah, blah, blah. So technically it's 10 point. That's the first significant is 1. 0 is significant because it's between two non-zero digits. And all non-zero digits are significant. But because the 0 is in between, the non-zero digit is significant as well. So that's 1, 2. This is my third significant figure. Why didn't I add 1 to it? Because the next digit is less than 5. So I can just chop them all off. And since we're looking at side, P being the side of the shape, the triangle, and we're dealing with centimeters, then this is actually 10.5 centimeters. So this is the length of the side I'm looking for. All right, hopefully that was helpful. So notice that I didn't just show you the formula and just plug in the values. I also want you to understand what these letters or variables represent. And again, just in summary, just so you remember, in the formula a squared equals b squared plus c squared minus 2bc cosine a, the what? The b and the c represent what? The b and the c, which is here again and here again, the b and the c represent the two sides that form the included angle right here of 81. An included angle is our a. In this case, given as p. That's why we have p here. And the two sides that actually form the included angle, even though it says B and C, they are B and C's, they are B and C, sorry, then we actually have different letters in this case, so we use R and Q to represent those. And obviously opposite this angle is our A, but in this case P. So in order to find P, we substitute from here all the way here with all the variables, plug them in our calculator. So we can actually plug all of this in our calculator, and we should actually get this number below here, round it off to 3 decimal places. Then we find the square root of it, give us 10.5 to 3 significant figures. Okay, so now you understand that. Let's go to the next question. We have triangle JKL, and we want to find the angle here. Can we use sine rule or cosine rule? Well, let's see if we have a full pair. Again, at the end of this line, should we have known, so we should have a full pair. One end we should have a known, the other end we have unknown. Doesn't matter which end we have the known or unknown. Or even if it's like this, we could have the unknown here, known here, and the other side, the line we have known. As long as on one side, one line we have both knowns, and the other we have one known and one unknown, then we use the what? Then in both cases we use the sine rule. As we see with cosine rule though, we need all three sides of the triangle. Doesn't mean all 3 sides has to be known, but as long as we're dealing with 3 sides and an included angle, then we're good. So let's check this out. Do we have 3 sides dealing with? Okay, we have this side given, We have this side given and this side requested. So we have three sides that we're dealing with. Two given, one requested. So that's three sides, right? And do we have the included angle? Yes, we have the included angle. So once we're dealing with three sides and the included angle, we use the cosine rule. Now, for the three sides, two must be given, or all three given. If only two sides are given, then we're asked to find the third side, but the included angle must be given. In the case we're given all three sides, then the included angle must be requested. Okay? So therefore, we're not going to use the sine rule, we're going to use the cosine rule in this case. So let's look at it. So the cosine rule again is a squared equals b squared plus c squared minus 2bc cosine of angle A. Alright, do we have the two sides, B and C, that actually form angle A? Let's look at it. We have two sides of a triangle here, and we have an angle in between both of these two sides. This angle is adjacent to both sides. So the included angle is given, and the two sides that form the included angle are also given. But we are requested the side that faces the included angle. So cosine rule. Since we are asked to find a side, then A will be our side in this case. So we have A squared. In this case, A is really what? Since we have a capital K here, then this side is going to be common letter K. And since the capital letter L, then this side will be common letter L. And since the capital J that we have here, then the side that faces it will be common letter J. Okay, so we can actually use those letters instead of the original formula letters. So our A is really what? The side we're trying to find, which is going to be K. So we can actually say K squared is equal to the two sides that form the angle B and C, in this case L and J. So those will be 10 squared plus 18 squared minus 2 times the 10 times the 18 cosine of the angle that's formed between them, which is 32 degrees. And then we say K squared is equal to, and we can plug this entire thing in our calculator. Your calculator should be able to do all of this one time. So I'm going to put 10 squared plus 18 squared. Now see, when your calculator can't do that, I'm going to just work out them in bits, because not everybody's calculator can actually work these out one time. So doing them in bits, I'll work out this portion, then I'll work out this portion. This portion here, everything is multiplying. So you have to work out all of that first. So for this portion here, the additional portion, that's 424 minus this expression here, our term. So we say 2 times 10 times 18 times cosine of 32, close bracket. And that gives me a minus 305.297 3146, etc. But I want 3 decimal places, right? So 305.297. I'm gonna chop all of this off. Since the first of those we're chopping off is less than 5, I'll keep my 7 as 7. So all of these will go. And so I'll say K squared is equal to, so I'm going to work that out, 424 minus 305.297, and that will give me 118.703. So K is equal to, now I need to remove the square root, so I square root both sides. What's the square root of 118.703? So I press the square root button, then I press the answer key, because this figure here is stored in the answer key. In the answer key, I'll have the 118.0703. So when I press the square root button on my calculator and then I click on answer, what's in the answer is really this. So I can just press the answer key after I press square root and then equal, and then I'll get 10.895. 3 decimal places, but I want 3 significant figure in my final answer. So that's 1, that's 0, and the 8 here. But checking the next digit, it's in the category of 5 or more. This digit I'm going to chop off. It's in the category of 5 or more, so I'm going to add 1. So we're going to get 10.9. And since we deal with meters in this case, then my answer is in meters. Okay, next. let's look at this one. Am I going to use sine rule or cosine rule? Now, what I have here is the angle. What I have here is an angle that I need to find. But remember, for the sine rule, we need what? Again, known, known, unknown, and known. The unknown could be any one of the k, anywhere that k is, but everything else has to be known. So we must have three. As long as we have three knowns and one unknown, then we use the sine rule. Is that the case here? Well, let's look. If I draw a line here, what I have here is I'll have one unknown from this end and one known. So the angle is unknown, the side is known. But the fact that we don't have any more angles, we cannot find a known unknown. Remember, we must have side to angle. If this is the angle, then this is the side. If this is the side, then this is the angle. So this is unknown and this is known. So we cannot find another pair, a full pair, to give us a sine, to use the sine rule. Can we use the cosine rule though? Yes. You said yes, you're correct. Cosine rule is when we're dealing with all three sides and the included angle. For the three sides, one could be unknown, which means that the included angle must be known if one of the sides is unknown. If all three sides are known, then the included angle must be unknown. Again, that's when we use the cosine rule. Okay, so for the sine rule, cosine rule, three sides must be given if you want to find what? An angle. Three sides must be given, we want to find an angle. So we have three sides given, I want to find an angle. So given, are we trying to find? Sometimes you may have to find a side, so that means you must be given what? Two sides and the included angle in between those two sides when you want to find the other side. So we're looking at this case. All three sides given an angle. But we need to identify in the formula what? The two sides that form the included angle. So if you look at this, we have A facing angle A. Right? So, and B and C are what? The two sides that form the included angle. Now, which two sides form the included angle here? What's the included angle? The included angle is what we're trying to find. So we have these two sides that form this included angle here. So this will be my B and my C in terms of the formula, the two sides that form angle A. And the side A here is the one that faces the angle. So notice A faces angle A. So angle A is here, in this, which is given as Q in this case, and side A is here. But notice that we're trying to find actually the angle, isn't it? We actually trying to find this angle. So here's the thing. Here's what we could do to make our lives easier. To make our lives easier, we can rearrange this formula so that A is in the is the subject, or close to being the subject. Notice that everything here is multiplying, correct? So what we can do, we can transpose this term here, negative 2bc cos A. We can transpose that term and then transpose the a squared. So what we're going to have is this portion becoming positive after transposing over the equal sign as positive 2bc cos A. And transposing a squared over, we'll have the b squared plus c squared and the a squared becoming negative a squared. Okay, and even to make this easier too, we can get rid of the 2bc. 2bc is actually doing what? Multiplying cos A. So we can get rid of this 2bc. Let's do that quickly. 2bc, right? 2's cancel 2, b cancel b, c cancel c. And we divide over here as well by 2bc. So now we have cos A equals this b squared plus c squared minus a squared over 2bc. So this little formula here will make it easy for us to work out the solution. So let's do it here. So cosine of angle A is equal to what? In this case, angle A, again, which is the side that faces the angle that is trapped or formed by B and C. And forming by these two sides is this angle. So it's really angle Q in this case. So angle A is our angle Q in that sense. What two sides that form angle Q? Is 13 and 12. What do we do with them? We square them and add them according to this little formula here, right? So we're going to square 13, square 12, then subtract the side opposite angle A. In this case, angle Q, so the side opposite is this side here. 11 squared over 2 times the B and the C, so 2 times the 13 and the 12. Okay, so this might make it a little easier, right? So we can work out the top. 13 squared plus 12 squared minus 11 squared equal what? 192. And 2 times 13 times 12 is equal to 312. And if I work this out, let's put 192 back in our calculator, divided by 312. The order is important, so make sure you write the 192 first, then division sign, then 312. And then you're going to get, now I get 8 over 13. So you want to press this button. Press this button that you're seeing. In case you get a fraction, you want to press this button. Standard to decimal. Right, press that button and you should see 0.615, 3, etc. But since the next digit is 3, then I'll leave this 5 as it is. Okay, and I'm going to transpose just the Q I'm going to transpose to the other side. So because I'm transposing the cos sign, then leaving the Q, then cos by itself goes over as cos inverse, since I'm moving cos over by itself. I'm not carrying cos Q over the equal sign, I'm just carrying the cos alone. So that's cos inverse of 0.715, which means that angle Q shift cos inverse. I'm going to just press the answer that I had before, and I'll get 52.0. After 0 is a 2 there, so I can just leave it as 52.0 and degrees. Alright, now I just use answer so that I really have the long answer instead of this. So if I actually do the shift cos inverse of 0.615, let's see exactly what would I get for that. Oh, I'll get 52.04. So because a 4 comes after the 0, we'll still maintain it at 0. So that still works. Okay, so let's see if we have another one. We have an angle to find. Okay, can we use a sine rule? No, because we're given what? 3 sides and the included angle. So now that we have the formula, remember it's the angle that we're trying to find. But we can replace opposite angle S is little s, opposite angle T is little t, side T, opposite angle U is little u. So A in this case is facing the included angle A. So this is the included angle since we have these 2 sides that form the included angle. So opposite the included angle is 5, alright? So that's 5 squared is equal to, B and C represent the 2 sides that form the angle, so that's 15 squared plus 11 squared. Does it matter if we have 15 first or 11? No, it doesn't matter if we have 11 first or 15 first. Because the order in which you add doesn't matter, right? So that's 2 times 15 times 11 cosine of the angle that's included between the 2 given sides. So the angle included is really angle S, but we do not know its measure for now, right? We do not know the measure for now. So what I'm going to do though, remember what we did last time, all right? I'm going to transfer this 5 squared over, all right? And then see this product here, because everything is multiplying here. This is really one term. We can't work out this portion, 2 times 15 times 11, and subtract it from the result of 15 squared and 11. But I'll say, I'm going to carry this across, so it becomes positive, 2 times 15 times 11, cos of S, angle S that is. I'm going to transpose the 5 squared over, so that's 15 squared plus 11 squared minus 5 squared. Then I can get rid of this 2 times 15, right? 2 times 15 times 11, I can get rid of those. Divide over here as well by 2 times 15 times 11. So what I have so far is that what? Cos of angle S is equal to 15 squared plus 11 squared minus 5 squared. Let's work that out. 15 squared plus 11 squared minus 5 squared. That's going to be 321. And then below we have 2 times 15 times 11. That's 330. So we're going to divide, eventually divide, put in the top number in the calculator first. So 321, then you press division, 330. Simplify that to 107 over 110, but I want the decimal, so I'm going to press the SD button. And what do I get? Okay, so let's press it twice. So you can see that is 0.972727, etc. So my calculator I have is 0.972 and a dash over 72. What it means here that after 0.972, there's no, after 72 you have another 72. I keep on having 72 again, and it will continue on forever. So what we can do therefore is press the SD button again, and it will now give us this one instead of actually this. So we can clearly see now that, okay, if we want 3 decimal places, then it's going to be what? 0.97, that's 2 decimal places. Now to put the third decimal place, we need to ask ourselves, should we add 1 to this guy here or maintain it? Well, check the next digit. It's actually what? 7. And 7 falls in the category of 5 or more, so we're going to add 1 to 2 and get 3. So it's 0.973. So in fact, you know what you could have done though? You could have put S, angle S is equal to cos inverse, and just leave this in your calculator. 321 divided by 330. Alright, rather than going through this whole drama there of trying to do all of that, and then you go shift cos inverse and you put in your values. Okay, so you can either put this in there as it's given there. If you actually round this off to 0.973, then you can press cosine inverse of 0.973, and then let me just put the last one, 0.973, close bracket, and you get your answer to be 13.3444, etc. So it'll be 13.3. And since we're dealing with angles, this is going to be 13.3 degrees. Relatively small angle. All right.